Okay, problem 2a, we want to solve for x. So we need to go ahead and find a common base here. That would be my advice to you. You could also take logs of both sides, kind of just different ways of doing the same thing. So what I'm going to do is I am going to recognize that 125 is the same as 5 cubed, and I still have that 2x plus 5 out there, equals 1 over 25 is the same as 5 to the negative second, and I still have my 3x plus 1 there. But notice these exponents, and what can you do when you have an exponent inside parentheses on a term with the exponent on the outside like that? Well, you can multiply them. So this is going to become 5 to the 3 times 2x is 6x, plus 5 times 3 is 15. So that's going to equal 5 to the power of negative 2 times 3x is negative 6x, and then negative 2 times 1 is negative 1. So now that these are in the same base, I could take the log base 5 of both sides of these functions, and I would get 6x plus 15 equals 5, equals negative 6x minus 1. So I'm going to add 6x to both sides to get 12x equals, subtract 15, negative 1 minus 15 is negative 16. So x equals negative 16 over 12, which you can simplify to negative 4 thirds. So x equals negative 4 thirds. And I was just checking my work and I realized I made a mistake. So that is a perfect example of you should always check your work. Did you catch the mistake I made? Because I distributed the negative to that term, but I did not make the 2 go over there. So I should have ended up with negative 2 there, not negative 1, which would mean that that is a negative 2 as well, which would mean that I actually am going to get negative 17 instead. And then I get negative 17 divided by 12. And I cannot simplify that. So negative 17 divided by 12 is actually my answer. And that's really ugly, but that's okay. And I know I can't simplify it because 17 is a prime number.